We are going to consider the example of an emergency ambulance service. We have 6 towns, and each of these towns needs an ambulance service. Those services can be in those cities themselves, but it can also be in another city that is at most 80 minutes driving time from that city away. So here we have an overview of the distances between the different cities. So for instance, for city 1, you can of course choose to put an ambulance service in the city itself. You see that city 4 is 80 minutes away from city 1. So if you have an ambulance service in city 4, then you don't need one anymore in city 1. Now the question is, what is the minimum number of ambulance services that we need in order to have all cities covered? And we are going to answer that question by first formulating this problem as a complete mathematical model, and then we are going to solve it by using the Excel solver. Then the first question is, what are the decisions that we are going to make? So we have 6 cities, and for each of the cities the question is basically, do we put an ambulance service in that city or not? That means that we are talking about yes or no decisions, so this will be a binary integer program. All decision variables will be binary. So what we are going to do is we are going to let xi equal value 1. And it's value 1 if a station will be located in city I. And it will be 0 then of course if not. And this will be defined for I is 1, 2 until 6. So we have 6 decision variables. The objective is now equal to, we would like to minimize the total number of ambulance services. That means that we are just going to minimize the sum of these decision variables. So we are going to minimize x1 plus x2 plus x3 and so on until x6. And then we also need to make sure that we have for each city an ambulance service in the city itself, or it should not be too far away. So we already realized that for city 1 it's fine to have one in city 1 itself, or we need one in city 4. That means that the first functional constraint will be that x1 plus x4, and this should not be set exactly equal to 1, because that can make the problem infeasible. It can be that in the optimal solution we will have one both in city 1 and in city 4, but we need at least an ambulance service in one of these cities. So this summation should be at least 1. And that's the case for all right hand sides. So in each city we need to have at least one ambulance service that's not too far away. Considering city 2, you see that there can be one in city 2 itself, but city 4 and city 6 are also fine. So it's x2 plus x4 plus x6. And this continues. So for city 3, it's either city 3 or city 5. I'm just considering the third row of the matrix and check all numbers that are not larger than 18. Then in row 4 we have 1, 2, 4 or 6. So it's x1 plus x2 plus x4 plus x6. Then for city 5 it's fine to have one in city 3 or city 5 itself or city 6. And for city 6 we need one in city 2, in city 4, in city 5 and in city 6. So these are the functional constraints. We are talking here about yes or no decisions. The decision variables only have a meaning if they have value 0 or 1, and that should then also be added as a condition. So xi binary, of course, for all I. And this is our complete binary integer program. We are now going to use Excel to determine the optimal solution. We can immediately implement the model that we have over here, but we can also start from the distance matrix. And if we do it like that, then the advantage is that if the distance matrix is going to change, then we can easily change it over here and then easily run the model again. Another advantage of using this distance matrix is that the number 18 can easily be changed. So we now have maximum driving time. If we explicitly add that to the Excel file, then it can easily be changed when needed. But let's start with the decision variables. So we have x1 until x6. So those are the decision variables, and they all have values 0 or 1. Initially we can choose to set them all equal to 0. So that's what we do over here. And then the objective will be the sum of those values. So it will be the sum of these 6 cells. And this is what we are going to minimize, because we would like to minimize the number of ambulance services. And then the constraints, and now we are going to transform the matrix that we already have into another matrix, because the only thing that's basically important is whether the numbers in this matrix are below or above 18. So what we can do, we can copy this matrix, let's paste it over here, and instead of those numbers we are going to check whether the numbers in the first matrix are 18, below 18 or above 18. So we are going to check if B2 is smaller than or equal to 18. Then we put a 1 here, otherwise we will put 0. The cell reference to I7 should be fixed, so we are going to use $signs over here, and then we get a 1. And then we can easily copy this formula to the other cells and also to below. And then you will see that the numbers in this matrix are basically the same as the coefficients of the functional constraints. So the first functional constraint has a 1 in front of the x1 and also a 1 in front of the x4. That's what we now see back in this Excel file. So there's a 1 here and a 1 here. What we would like to have for the first functional constraint is that x1 plus x4 should be greater than or equal to 1. And x1 plus x4 in this case is the sum product of the cells that we have over here and the cells that we have over here. So if we calculate this, then the value of x1 is multiplied by 1. Plus the value of x4 is also multiplied by 1. And the other decision variables are multiplied by 0, so they cancel out. And that's exactly what we would like to have. This should be greater than or equal to 1. All right hand sides are equal to 1. We are also going to copy this, and we are going to copy this formula downwards. But before we are able to do that, we should first fix cell references to the cells in row 10. So this should be fixed and this should be fixed. And now this should work. So let's copy it downwards. So these 6 numbers should all be greater than or equal to 1. So let's try if we put, for instance, an ambulance service in city 1 and in city 2. And you see that cities 1, 2, 4 and 6 are covered. City 4 even is now covered by 2 ambulance services. But then we miss one in city 5 and in city 6. But we can of course use the solver to determine the optimal solution. So what we are going to do right now is we are going to data and then to the solver. And then we are going to choose that we would like to minimize. So the objective value is this cell, the 2. We would like to minimize that. We are allowed to change the values of the decision variables. So we can change those values. And we have constraints. So we start with the functional constraints. First we have that the cells over here should be greater than or equal to the cells over here, element-wise. And the second set of constraints is that we have the binary constraints. So the decision variables, we refer to the cells where we have the values of the decision variables, they should all be binary. So this makes sure that the 6 decision variables can only take value 0 or value 1. It's linear, so we are going to use the simplex method to determine a solution, and then we can solve the problem. And then let's see if we find a solution. Let's see what the outcome of Excel will be. We indeed have that solver found a solution, and then you also see what the solution is. So here you see that we put an ambulance service in cities 3 and cities 3 and 4. And if we do that, then you see that all cities are covered. We can also add the optimal solution. So the optimal solution will be x1 is 0, x2 is 0, x3 is 1. So don't forget the zeros if you write down an optimal solution. x4 is equal to 1, x5 is equal to 0, and x6 is equal to 0. So this is mathematically the optimal solution. The optimal value is equal to z is equal to 2. So we need at least 2 ambulance services. So this is the optimal solution mathematically. Also good to write down the optimal solution in words. So that means that we need an ambulance service in cities 3 and 4. So that we need 2 ambulance services in total. Validation is also always important. If you can check your solution, let's do that. So for city 1, we don't have an ambulance service in city 1, but you see that city 1 can use the one from city 4. The same for city 2. City 3 can use its own ambulance service. City 4 can also use its own. City 5 will also use the ambulance service of city 3. And city 6 will use the ambulance service of city 4. So you see indeed that all cities are covered if we use this solution with 2 ambulance services.